Smart Textiles, Smarter World. Spark innovation with the SmartX community.
So we are here at the Smart Textiles, Smarter World podcast, and we have today Kimmo Vanni from HAMK University. So we are going to talk about exoskeletons and a really special program that they have developed.
Yes. Okay, I can tell something about from our university. So I'm coming from HAMK University, and our longer name is Häme University of Applied Sciences. So we have about 10,000 students, about 800 employees nowadays. And that kind of financial figures, turnover is about 73 million. And we have 100 of our staff members who had a doctorate or licentiate degrees.
Mm-hmm.
And we have our projects about 15 million euros annually. We are running quite many projects every year, funded by our local funders or national funders. We also have some international funders, but greatest part of our projects are coming from our local or national funders, like these the ministries or the other similar issues. This is a little bit older. Older photo, older picture. I have a new one somewhere. I have to update it. But we are also part of the RUN, which is the regional university network in Europe, and we have now 10 universities in our network. We are working together. We are planning joint study programs and degrees. We are planning that kind of joint research project, and also the doctoral pathways, which is also nice regarding our upcoming master's degree. When the people they graduate from our master's in wearable intelligence, they have an option to continue their studies and to have a doctor degree also from some of our RUN partner universities. And in this RUN regional university network, our university is responsible for pedagogical development at European level. And our newest one, which is not in this picture, is Technical University from Liberec, from Czech Republic, and they have a quite strong faculty of textile and textile engineering. They are really
advanced. A lot of
advanced.
it textiles, I would say, because I remember them on a conference, and they have quite doing a bit of development on e-textiles, especially.
They are especially, yes, and they have a fiber technology, and they have a nanofibers, and they have nanotechnology, and they have smart textiles, and they are really good. And I'm quite happy that we are getting them on board. We are also operating some of the project we have in Africa. We are quite strong in Africa. We have some project in Asia. I have one project together with quite famous Zhejiang University from Hangzhou. The Zhejiang University was in a Shanghai list, which is some kind of international ranking list of the universities. They were number 5th in biomedical engineering. It's really high. And in overall list, if I remember right, they were 24th and quite advanced. We are developing together with them 10 credits package regarding how to use exoskeletons and exosuits for preventing sports and occupational injuries, and how to give rehabilitation by using exoskeletons and exosuits if somebody someone has had the injury. So that's quite good issue that we are getting also that kind of expertise from China. We have this multidisciplinary education, and our master's program is related to design. It's related also to health and social services. technology and transport and information and communication technology. Somehow it's also related to entrepreneurship and a business, because we want that people who join our master's program, they have a option or chance to establish a company or to work as a business professionals.
That's
And
a
we
really
have
hard part
yeah,
for, especially for e-textiles. Be a business, develop a business behind an
yes,
e-textile.
it is. It is, and we are looking forward that what are the future options for the people who graduate? What kind of business they are able to create? It is something related to design of exoskeletons, exosuits, or smart textiles, or is it related to resell of something?
Yeah, no,
Sorry,
it's
or
and for example,
fabricating or something. So it depends, and we know that if you want to have a textile, that kind of smart textiles, you need all the machines and machinery. But
no,
3D
and
printing is
it's
changing it a little bit.
yes, and not only the value chain, but once you have the product, to
Yeah,
sell that product to the market, that's really complicated.
yeah,
Because if you were like an end user, you want like something functioning perfectly. So as a business developer, you have to figure out all the steps from the value chain. And when you are selling, you need to sell the device, the
yeah,
service, and the maintenance, because
yeah,
these
yeah,
devices, they need maintenance.
yes. And also in wearables, what I have discussed with my colleagues and what kind of tests we have had regarding exoskeletons, the user experience is quite big issue. So technology is about 1/4 or 1/3
Mm-hmm.
of the whole system. If you have a proper technology which is working well, uh, the more important is that how people are wearing it and how they are feeling it.
Yeah,
What is the user experience? How do they find it useful? And is it easy to wear on and off? And is it easy to use? So those are the big questions. Even you have a nice technology, you have to take into account that the wearable, a real feeling of the devices, and
yeah,
that's the different issue compared that you are developing, for example, hand tools
yeah.
or bicycle or something else. That's challenge. So we have 3 study modes, and in our wearable intelligence program, we are using that kind of part-time studies while people are working. So we had first in our idea to have that kind of full-time studies where people are at the university, uh, but we realized that because our program is focused on people who already have at least bachelor degree, uh, and they are working and they are adults,
Mm-hmm.
it's impossible for them to move to Finland for 2 years. So they have
Yeah.
families, they have their workplace, they are from different locations, from Europe, from Asia, from Finland. That's the reason why we are offering that kind of part-time studies while working. Of course, they have to do themselves a little bit more things, but we realize that it's not going to happen if we have that kind of on premises studies that
Mm-hmm.
people have to come. And I think that it's the new normal nowadays to offer
Yeah, I think
part.
once you have done the degree, the master, it should be a bit adapt in order that you can combine, for example, working or like with families.
Yes,
Yeah.
because people are doing in this way also. They must their doctoral studies
Mm-hmm.
quite often. So they are doing their doctoral studies while they are working in the companies, and um, they visit university or their research team every so often. That's quite common way. I did my PhD that way as well. So I visited university every so often. But in my case, it was easy because the university located in the same city where I'm living. So
Well,
it,
then it was like walking distance.
yeah, it wasn't big issue to visit university. But of course, we have these online tools available nowadays. We have
Mm-hmm.
quite nice channels. We have um, quite nice cloud services and everything else, which makes possible that we can offer quite well that kind of part studies.
Yeah, nice. And now we are going to, okay. Yeah, let you talk.
Yes, yeah, I take this. Okay, quite quickly with these research areas. The smart bio. We are quite strong in actually in biotechnology and smart systems, and we have smart education. We are educating also teachers, and we are focusing on also that kind of what kind of in which way we are giving a good education and in future. And our wearable intelligence, it's related to smart build research. It's not a unit, but let's say that it's a research approach that we are developing smart and sustainable built environment, and also new technology for people who are working in environment, that kind of smart environment. Yes. Some words and thoughts regarding our test, what we have already done. Actually, I started a little bit background. I have a background
I
from.
think we have to
Yeah,
explain, just in case someone is not outside from the textile
yeah.
industry, what is an exoskeleton?
Yes, that's good. And from my background, I have a background from social robotics research, more than 15 years, almost 20 years. And social robots, how they are relating to exoskeletons. They had a little, they had a, they had a not similar, but let's say that both of them are relating with people. So social robots are relating and working with people by understanding the emotion and the human emotions and the human movements and that kind of thing, and supporting people in a social way and collaborating with people. So I started that kind of research more than 15 years ago, but I also added exoskeletons to my research portfolio about 2010, okay, about 15 years ago as well. And exoskeletons, which are really wearable technology and assisting people in a physical way. We have that kind of rigid body devices. They can be passive or active exoskeletons, so-called wearable robots, using elastic materials, different mechanical solutions, and spring powers. They are able to distribute power, or they are distribute load. They normally without sensors, without motors, and no batteries. So they are quite handy if you have a work where you need a device which is giving you power all the time. So you don't have to charge them or load them. They are working all the time. The active exoskeletons are equipped with motors and sensors, and they are devices which are providing you extra power. So you can adjust them quite easily, the torque of the motors, and but you need the batteries and
Yeah, that's
how you are generating the power to motors. You need that you can use the servo motors or linear motors and various technologies you can use it. And nowadays the batteries they last about 8 hours, from 6 to 8 hours, one battery.
And are they heavy, like in the exoskeleton, the ones, or?
The weight of the exoskeletons is the lightest exoskeleton what I have in my lab is about 3 kilos.
Okay.
And the heaviest is about 8 kilos.
But
But
it's batteries included.
It is battery included, yes. So the batteries are quite light nowadays, and that's one issue they are nowadays developing, the new batteries which are a little bit flexible, and for example, that kind of wearable technology, what you're wearing on, it is a big bonus that if you have a batteries which are flexible, which is adjusting according to your body dimensions. So they have that kind of developing, or actually they have that kind of flexible batteries, but for some reason they are normally packaging them to that kind of rigid plastic box or something else.
Okay.
I checked it, by the way, once to one battery from my tablet computer. It was flexible, flexible material.
But I've
So
seen them, but I thought there were like developments that you can actually
twist it
stretch them, yes, a
or
little
stretch
bit,
it. Yeah,
yes.
yeah. It is possible, and but it has developed a lot, and also how you are controlling power. Uh, it also has developed a lot, so that devices are not heating. Of course, motors are heating, and they are getting extra energy. But I would say that you are getting quite nicely about 8 hours or 6 hours power from exoskeleton power by using quite reasonable size batteries, that you don't have to
And
carry 2 kilos batteries with you.
we see here some images, but which applications do you foresee, like exoskeletons? We see, like, for example, workers, like
Yes,
forestry
yes,
workers.
yeah. The workers, they actually exoskeleton research quite. It started, in my opinion, it started from rehabilitation. So, for example, the Exobionics, which is the company, U.S. company doing exoskeletons for rehabilitation purposes, they developed also that kind of passive exoskeletons for workers. And quite many companies are using that kind of supported technology, exoskeletons, for supporting the workers who have to work or who have a work task where you have to keep your hands up,
Or
like
repetitive
assemble.
movements as well.
Yes,
I've
yes,
seen them for.
yeah, yeah. Static positions where you have to keep your body position and the hands up all the time. For example, assembling something, so that you have to lift your hands, and also that kind of repetitive task where you have to repeat task quite many times during an hour and during a day. But it's good to know that when you are using those exoskeletons, for example, upper body exoskeletons, those are not something like to superhuman power. So it is supporting your hand maybe from 2 kilos to 8 kilos lifting power. It is something people normally ask that, are you able to develop exoskeleton that I could lift 60 kilos?
No.
Yes, we are.
Yes.
yes, we,
Okay.
yes, we
Okay.
are. So it's not a technology issue. We can develop that kind of exoskeleton, but then we normally ask that, where do you need it? How many times in a day you have a issue that you have to lift 60 kilos? Because if I remember right, our occupational health regulations say that the maximum load you are able to lift without any additional devices is 25 kilos. So
Okay.
if
So
you
yeah.
if you have to lift heavier things, then you need some kind of assistive technology, and normally it is automation or whatever technology it is when you're lifting, and when people are doing that kind of heavy things, and if they are doing it every day, uh, and the task is to lift heavy things, so normally they have automation and that kind of automation technology.
Yeah. No. I
Yeah,
understand. And for rehabilitation, have you tried them? So, because I mean, I know that they are used like in industry, like as you say, for lifting, for repetitive
yeah,
movement,
yeah,
for supporting certain workers
yeah,
that they need to walk long distance with a bit of
yeah,
weight.
yeah.
But
Like,
rehabilitation,
yeah, in rehabilitation we had we discussed with the local hospital, and we had an idea to test those with patients who are not anymore in a clinic treatment or in the hospital. Uh, but we are now doing it when we started now the project together with Zhejiang University from China, and in our plan we wrote that we are testing now that kind of commercially available exoskeleton in rehabilitation with the volunteer people. And the challenge here in Scandinavia, in Europe, is that um, if you take that kind of um, exoskeletons, which is for industrial use and commercial exoskeleton for industrial use, they don't have um, this medical device certificate. So you are not able to use them in the hospital environment or in the hospital. You can use them for people who have had an injury and they want to rehabilitate themselves, but not as a part of the clinical process. So
Yeah,
and
it's like a
that's a challenge.
well-being device.
It is something like a well-being device. But the other option, when you ask it, is it technology where they are, sorry, the industry where they are using it? I think that one of the quite promising field is sport and leisure. So they have now like a hypercell, which is active exoskeleton for lower body. So it is moving your legs. They mentioned that it's the first exoskeletons for hiking. So it makes hiking a little bit easier if
Okay.
you have if you're okay a little bit older, and if your physical capacity is not good as anymore, for example, based or you have had some injuries, or you have some muscle problems or muscle nerve problems, so you can use the hypercell for hiking, and it is assisting you about with a one battery about 30 kilometers. I have tested it. It was
And
funny. It was nice.
okay.
It is working quite well. It's lightweight. It's quite affordable. It's the price level is nowadays about 1,000 euro, a little bit higher, about
Okay.
the cheapest version. And that's funny when I checked that what has happened during the last 10 years for technology and the price of the devices. So the price is quite low now compared to what we had about 10 years ago.
Mm-hmm.
And technology is quite robust now. And,
Okay,
and,
yeah.
and you can use it quite easily. But it's the design issue, and we have discussed, is it socially acceptable that you are using that kind of devices when you are walking on a street? So what people think about,
I mean,
are
I
you
think it depends because if
yeah,
you have like a disease or like, for example, people who is working, who is waiting for a hip replacement or
yeah. But who is starting it? So who is starting it that you see, for example, in the big cities in Europe, people wearing that kind of assistive devices which are helping you for walking. I haven't seen them. I've seen sometimes something in Japan, in Akihabara, in Tokyo, that
mm-hmm.
kind of devices, but it is part of the Japanese culture, so that people can use and test them there. But I haven't seen in Europe anywhere that people are wearing that kind of assistive
I mean,
devices.
I have not seen it even in hiking. I would like to try hiking one, but I mean, I think it's just one person starting, and then you will start seeing other people. It's how it
Yeah,
works. There's all one the starter, and then the people who follows.
yeah, yeah. I don't know who is the first one who is using. Maybe we have to pick up some famous people who are
Who
using it.
is in going
And
to be?
yeah. And it's also design issue. What kind of design you are planning? So and is the design acceptable? Is it the fashion? See, somehow I feel that when we are developing and designing exoskeleton, exosuits, and smart textile, we have to take into account also fashion. If we
No,
want
no,
that people are
absolutely.
using them, yeah, if we want that people are using them, if we have a devices which are somehow, the fashion is something like a rehabilitation device or really that kind of industrial devices, people are not using them when for leisure activities or sport activities.
Yeah, no,
So
no. I
we,
mean, I definitely think that if you integrate it with fashion, many people will be.
yeah, yeah.
We will see it. Yeah.
And Anouk Wieprets from Netherlands,
Hmm.
she's Dutch. Anouk has done quite nice design for exoskeletons and prostheses, and she's quite famous for that kind of a little bit futuristic exoskeletons. And
No, no, I have seen as well from Quit Circuit that they have done as well some developments on protheses and
yes, yes, yeah. But what is the future trend? I'm quite convinced that the future trend is exosuit and smart textiles. So we are a little by little getting rid of that kind of rigid body exoskeleton. Of course, the rigid body exoskeletons are useful also
Mhm,
in future, but the workers, they are looking forward to that kind of a real exosuits, which are like clothes like devices that it's easy to wear,
mhm.
like a normal clothes. But the challenge is that how you are creating power, how you are creating force by using that
That's,
kind of textiles and exosuits.
I mean, I think that's the challenge that
It is
the
challenge.
textiles have right now that you don't, I mean, it's really easy to put like a suit or something, but you need the power, and
You
that's a
need a power.
must.
Yes. And they have, or like we know quite well that that kind of textile actuators are available.
Hmm.
So which are based on the textile fibers coated with that kind of reactive materials,
Hmm.
and you can manipulate them and to create power. But the displacement is a challenge compared, for example, the servo motors or linear motors. With a motor, you can create the displacement of, and meaning that you are able to create power which is lifting your hand in real and or moving your leg. But if you are using that kind of fiber-based textile, the fiber-based the textile actuators, it's quite challenging to make the actuator which is moving your leg.
Hmm.
But
Yeah.
of course technology is developing and people are doing research and
Hmm.
experiments, and maybe we have in future we have that kind of textile actuators.
Yep.
I had some publication, but I we have published during the last years quite nicely together with our Chinese colleagues and also together with Danish and Swedish. So we have in our master's program we have partners, the University of Borås from Sweden, which is quite well known for the people who have a
Yes.
background from textile or smart textiles. And then we have the South Denmark University from Odense from Denmark. They are
Hmm.
quite advanced in robotics and both are quite well known European or Scandinavian universities. And then we, of course, what I already mentioned, we have this Chinese university, the Zhejiang University, and they are quite advanced in uh, rehabilitation and sports science, biomedical engineering. So during the last years, we have published together with them some papers. And here's we have also developed some exoskeletons
Nice.
together with them for industrial use. For example, the one of the biggest Chinese electrical companies, we developed one exoskeleton, the upper body exoskeleton for them, and we tested it also in. We are testing also those exoskeletons in different use cases, not even if we have developed exoskeleton for electrical company, we tested it also that how is it workable also when we are picking up
Hmm.
fruits and berries. Uh, it wasn't.
It was okay.
It wasn't okay. It worked, but it wasn't so good for that because it was developed for the electricity company. So
Okay.
in
Well.
totally different work, and that's the good idea to, or the issue to understand that if you are developing a device, a certain work task, it not necessarily work in other work task. So it's not a
But
universal. Yeah,
it's
it's not
really
universal.
important as well to test it.
It's important to test. Yeah, yeah. But I'm quite so happy to see that they already like what I mentioned, that kind of smart textiles and exosuit. They have these, for example, the one example is the right trousers, where they have developed that kind of future trousers
Mm-hmm.
with have all the artificial, it has all the artificial muscles, it has MIU sensors, it has embedded technology, and also I think that because it have embedded technology, it have some AI as well. And the AI, the embodied and embedded AI is one topic in our master's program. And it's quite interesting to see that we are okay. People say that we have AI everywhere, and and we have to
Yes.
take into account AI everywhere. But in robotics, we have had embodied and embedded AI all the time. So it's not it's not new issue in robotics and automation, but how we are embedded it into textiles and how we are
That's
using, how
yeah.
we are merging AI, embedded and embodied AI in textiles. That's new, and that's what we are. What we the one topic in our master's program, and this Southern Denmark University SDU is responsible for that package. They are quite advanced on that. Sorry.
So now the master, that was
Now
the
it's
key.
the
Now we're
master.
going to introduce the master. I
Yes.
think it's a nice, I mean, a nice program because it's four universities, sorry.
Yes. Yes.
And it's really prepared for people, I
From
mean, for,
different.
working at the same time.
Yes. It's for people who are working at the same time and people who already have a background from engineering,
Mm-hmm.
and people who have also a work experience, at least 2 years work experience before they join the master's program. And that's a Finnish system that if you are doing a master's program in the University of Applied Sciences, you you have to have this 2 years work experience before
Mm-hmm.
you can start your studies. In our case, I check it from our webpage that when the candidates should have their work experience, we have this application period starting on January 26, the 7th January 26, and that's the joint application period, and it's ending 21st January. But in addition of this joint application period, we have also that kind of direct application period, which is starting on February.
Okay.
So if somebody is willing to apply, we have this first application period, and then we have a direct application period, which is longer, and which is after this. It started it will start on in the beginning of February, if I remember right,
Okay.
and it's also 1 month about. I I can check it a little bit better. That what is the uh, that kind of direct application period. Uh, we are collaborating, like you said, with 3 other universities, so we have 4 universities altogether. The program is not something like that. We just had an idea that hey, let's have that kind of program. So we have prepared this more than 3 years. So quite carefully we have prepared this, and we have checked many issues that how to how to merge together different topics and what are the important topics and what is the expertise of each institute of each universities, and we spent about 3 years for planning it, and it was supported by the Finnish National Institute for Education. And now we are in this point that we are now marketing it and launching it next year. And it's 90 credits. The master's program are normally in Finland 60. that kind in university applied sciences. Those are normally 60 credits. And we have this study mode, we have this part-time, and then we an online with intensive weeks. So we are organizing intensive weeks where the students are the professor. I can say they are students, but they are professionals, where they meet
Okay.
they meet each others, and during the intensive week we have that kind of hands-on issues, a hands-on work where we are really creating something or developing something or measuring or testing something, which is not possible for them when they are working online. So when they gather together and have an intensive week, we are able to do that kind of hands-on, real practical
And
testing and designing.
they are like four intensive weeks during the program,
We have
or
about 4 intensive weeks, yeah, during a program,
but it's spread over the 18 months.
yes, it is spread over. Yes, it is spread over 18 months, and we have figured it out now the weeks, and we are announcing it in our webpage that when we will have the intensive weeks, uh, we understand that maybe uh, not everyone are able to join the intensive week, and then we have to think about that what kind of um, things and what kind of practices we are providing for them who are not able to move, because if you have people who are coming from different countries and they have their
Yeah.
work, so we understand that it's not maybe possible for all of them to join when we have this intensive week. But it doesn't mean that if you are not able to join the intensive week that you are not graduating. so
Okay.
so we know people that and we have some options also. Of course, we hope that people are able to join, and it's also economic issue. So we are not willing to do so that people who are coming, if you have some candidates coming, for example, from Asia
Yeah, it's
so it's quite expensive for them to have to travel every so often to Scandinavia and to
mhm.
book the hotels and everything else. So we try to do these things quite flexible and so that it's not impossible for the people.
Okay.
But our masters is 90 degrees this credits. It's 90 credits. It's 30 credits more than normally we have. And why? Uh, we have normally these out of the 60 or out of the 90, the final theses are 30. And we planned that if we have the final thesis is 30 and we have only studies 30, if we would have 60. So can we say that people who are graduating with studies with 30 credits are professional in exoskeletons and smart textiles? If they have that kind of, for example, 10 credits course or 5 credit course of smart textile, and quite well, the professor Fernando Seoane from Boros
Mhm.
University, Fernando said quite nicely that we are not able to say that people with 30 credits are professional in smart textile. And I agree with Fernando. so we have to give more than 30 credits courses. So we need more for giving them um, information so that they can say that I have learned something, and the study 60 seems to be
Yeah.
quite good, and the final thesis 30. Then it makes sense. Then it makes sense. Uh, we have this that kind of profiling studies. The 46.5 credits is profiling studies. Then we have these optional studies, 13.5, and the thesis is 30. And the optional models are interesting. We have two optional models. The one is Smart Textile Product Development with University of Boros. And in this optional model, people are moving to Sweden.
Okay.
who are able to do that. So they are really spending their time in Boros,
Mm-hmm.
and they are really doing uh, developing smart textile products by using the devices of University of Boros. Knitting and weaving, whatever they have there, jacquard.
Yes,
uh,
no, they have,
but
and we have to say that University of Borås, they have really, really, really good
they are really
facilities
good.
for knitting. Yeah.
Yeah, they are merging textile, they are merging electronic to textiles, they are doing that kind of with the conductive materials, and they are really staying there. And we discussed that, and we realized that it's impossible to develop a smart textile product and to do it online. So that's the reason why people who select this model are really moving to Sweden.
To Sweden.
Uh, yeah, and I would like to be there. So it's Borås is a nice place, and the university is nice. And if somebody has someone has option and a possibility to stay about 6 or it's about 6 weeks or 7 weeks in Borås,
Mm-hmm.
it would be great. Then we have this other option, exoskeletons for work and sports rehabilitation, and it's together with Zhejiang University. In this case, people they don't have to move to China. So
Well,
this
yeah.
is
Well,
this we haven't mentioned here that it's the online. Yes, it's the online model. Even if the Zhejiang University and Hangzhou is a nice city, so but they can take this model online, and we wanted to create this option for people who don't have possibility to move to Sweden. So for 6 weeks or 2 months. So
mhm.
that's the reason why we have this
Yeah, yeah,
option,
yeah.
the online option, and, and let's see what's going to happen. Here's the structure of the studies a little bit detailed. We have that kind of uh, common model for everyone. It's a changing operational environment and research-based development. It's common model for all the master's students uh, in our master's programs. Number one, and but starting from number two, the wearable intelligence and biosensor in human performance. It's the model that we are responsible for, and we are doing the materials, and and we try to do quite uh, nice materials regarding also the biosensors, and what kind of future biosensors we will have, uh, which are measuring
Mm-hmm.
the sweat, and also what we are able to measure from the human, from human. Of course, we are able to measure uh, these EMG signals and heart rate variables and everything else. Um, Actually, I have one project in University of Tampere where I'm measuring stress, and just now it's
Okay.
we are measuring techno stress, and
Wow.
it's related
Mm-hmm.
that how what kind of heart rate variable we are taking, but we are also measuring the skin conductive. We are using galvanic skin conductive measures, so-called EDA measures, for for measuring stress, but not only
Wow.
a negative stress, but also positive stress called
Positive stress. Okay.
eustress. Yes, so
Wow.
we try to understand that when stress is positive, and that's something we can do also in future by using smart textiles.
Yeah,
And
probably. I
yeah,
mean, yeah.
yeah, it's quite interesting. And then the introduction to smart textiles, which is also 10 credits. So it's uh, designed
Because
and implemented by Boros.
because I think that's something important that you need to have a technical degree, but you don't need to be an expert or you don't need to be working in smart textiles
Yes,
to apply to the
that's true.
master.
That's true.
Okay.
People who are willing to join, they should have, let's say, that applicable engineering degree.
Mm.
It could be from textile engineering, and it's really focused already if they have a background from textile engineering, but also people who have a well-being technology, for example,
Mm-hmm.
who have a biomedical engineering, maybe somebody who has background from ICT. We have also mentioned and discussed that what about if somebody has a background from physics or sports science?
Okay.
Yes, it is possible if they have, because we have those different degrees in all over the world. So we have to think about a little bit that what kind of degrees people have in Europe, in Asia, and if some and also somewhere else. And we don't have the same degrees uh, in Scandinavia, not necessarily the same degrees in Scandinavia. So we have interviewed people who have a background from physics, and if you think about that, what kind of background they have? Are they able to study in the program? They are.
Yep.
They are. And why we have mentioned that you need to have an engineering degree or something like that. It's based on that we want to guarantee that people are able to study, that they are able to study that kind of um, topics like smart textiles or embodied AI, that they have the mathematical skills or
To
engineering
understand, yeah.
skills, yes, uh, at the level that they're able to do that. And that's the reason why uh, uh, we don't have a possibility for people who have a fashion design. So we are not able to take candidates on board who have a fashion design, because we were a little bit worried about if the mathematical skills and that kind of technical skills are good enough for joining the program, and yes, and we thought that maybe not, and that's the reason why we. But if somebody want to apply and they have they have graduated and they don't have in their degrees the name of engineering, that's not the problem. They can ask from us if they have a background, for example, from chemistry or physics or sports science. That
Mathematics as well, maybe.
mathematics, yes, if they are able to join the program. And we are quite flexible, so we understand that maybe they have a background good enough for and that kind of study skills and ability to study engineering and exoskeletons and smart textiles. And then we have this is embodied AI. It's designed by, like I mentioned before, it's designed and implemented by Southern Denmark University for Moderns. It's 15. It's quite nice package as well. And we have developed the master's program so that those topics are connecting somehow as well, so that they are not something like the separate issues that you have an embodied AI 15 and then you have biosensors and they don't have any connection between. So we have planned so that those things have connection between. And then we already mentioned these optional studies.
The two modules.
Two models, and the master thesis. We have an idea, by the way, regarding the master's thesis, that it's the research based. So people are researching something and they are creating something, uh, and they can pick up the task or on a topic that's suitable for the degree program, and we have an idea that we are getting, or we have the supervisors at least from 2 universities. So we can have the supervisors coming from our university and from Borås, or from our university and from Southern Denmark, or then the one option is from Southern Denmark and from Borås. We want to have that kind of the thesis and topics which are linking two universities and the supervisors together.
Okay.
It's also option and possible to have a supervisor from Zhejiang University from China. It's also possible if somebody is doing which is quite strongly related, for example, to sports science and smart textiles in sports. So we can ask also professor from Zhejiang University to be the supervisor of the thesis.
Okay.
We have a good connection to them, and we have already agreed that we can supervise the thesis so that they can join as well, and we can also join if we want to, if they need our uh, expertise and supervising their
Okay.
thesis. It's
No,
possible.
that's good to know. And something I think everyone will wonder, it's like exams. Are we going to have really exams so that we need to travel to the exam, or it's going to be more
Mm,
towards projects?
it's more project. So normally
Okay.
we have these master's programs in a way that we don't have exams. We have that kind of project work, and we give tasks from the students, and do this one and do this report and do
Mm-hmm.
this one. This is more like adult like studies, or it's quite comparable also how people are studying their doctoral thesis, that they
Mm-hmm.
don't have exams, but they have that kind of
Like projects, yes, or
project. Yes,
deliverables.
yes. And also we are quite happy if we are planning the project that people are doing together. We can have that kind of individual project and that kind of individual tasks. But normally in our master's programs, we have that kind of group work that
Yeah.
do something in a small group with a people of 3 or 4,
Mm-hmm.
and they can do a plan, or they can do a report, and do some kind of mini review, that they can have some kind of mini literature review or something like else, something like that, or they can design together something, and it's that's
Yeah.
the part of the
Mm-hmm.
they course. Uh, but the challenge is of course always, in that kind of group work, that if you are giving them a grade, we are giving them a number from
Yeah.
from a course. How we are evaluating them? So uh, if we don't have any individual part of it, so are we giving, if the report is nice and it's good, because we have our grades from 1 to 5,
Mm-hmm.
are we kidding? Are we giving all of them? If it's nice, are we giving
Mm-hmm.
all of them 5? Yes, yes.
Yeah.
Or how we make a
I mean, actually, if
distinction
it's a
between?
group that is a group work, it's a group work, right?
Yeah.
Or I mean, you can ask everyone to evaluate everyone, but it's a bit
Yes, 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 yes. But
so.
it's quite easy regarding people are adults, so it's much more easier compared that we have the younger candidates.
Yeah.
And I remember also regarding my own studies, especially uh, one memory when I was studying biomechanics in the University of Jyväskylä. So I have one of my masters from biomechanics, and I remember we have a we had a biochemistry course, and it um, uh, it had about 3 or 4 reports and the tests, that kind of group reports, that you have to you have to write 3 or 4 reports concerning or regarding
Mm-hmm.
the lab tests. And I had 4 person in my group, and I was waiting for that somebody is doing something, because I was
Mm-hmm.
graduating. I was graduating. That was the final issue I had to do before I'm able to graduate. So it's a long time ago, but anyway, so I was the only one who wrote all the reports. So
Yeah. No,
because I have
I
to do
know that that can happen on the groups.
it
But I mean,
happens.
I had a really good experience. So while I was
Yeah.
studying in France, I had a really good experience that we all collaborate and we had something
Yes.
there.
But I
So
understand the case, because I was the only one from our group who was graduating. So I was
yeah.
a little bit hurried to get it the final course, the ready, the
Mm-hmm.
biochemistry course ready, and the other ones they didn't graduate. They had an idea to graduate, after half a year or half the year or 1 year. So they didn't hurry up at all. So
Yeah,
so
yeah, yeah, yeah.
I wrote everything myself, but I'm not
Wow.
sorry at all. But it was that kind of experiments. I have told sometimes to my students that sometimes if even if you have a group work, maybe you sometimes have to work alone. So it
Yeah, but I mean, you
depends.
learn something out of it as well. So, yep,
Yeah, it depends. It depends
it
what is your
depends. Yeah,
goal
yeah.
and what is your schedules and everything else. Uh, but I learned. I don't
Yeah.
know if others learned, but I learned. So what is the main issue? The main issue is that people are learning something.
Mm-hmm.
So we want to create, and we wanted to create the course. We wanted to create to create the program that people are really learning something, and they can say after the master's program when they graduate, they can say that I understand something about smart textiles, exoskeletons, and
Mm-hmm.
wearable intelligence, and they have options to operate in that field. They are
Or
able to design, or they
that
are
could
able
be
to do something.
the other option. That's something that is happening quite often, is that when you know a little bit about the subject, you feel you know nothing about it.
Yes, yes, sometimes it feels, but when you discuss with people who don't have any background of the topic, then you know that
You
they
know, yeah.
realize that, of course, I know much more than they know.
Yes.
And I don't know, because from research, if I think that what's going to happen, for example, in exoskeleton or robotic research, I have also the same feeling sometimes that I didn't know that I should be more aware of this topic. For example,
Mm-hmm.
this sensor topic. But it's natural that you are not able to know, or you can't know because you are not doing that kind of research just now. You are doing something else.
Yeah,
But
no, no,
let's
but I
say
mean,
that,
I
yeah,
have the feeling that the more you know about something, the
yeah,
less you feel you know about it.
I know what you mean. I
Yes.
know what you mean. Yeah, that's quite common sense also, or common feeling.
Yes.
Also, even if you are doing research, so and new research is coming, the new research is coming all the time, and the new results are coming all the
Mm-hmm.
time. So, for example, regarding my stress research, what I'm doing, the techno stress research, I checked it yesterday, one article, and we are using the smart sensors, the smart watches, and that kind of
Mm-hmm.
devices. We try to understand, are you able to use that kind of wearable devices for um, for measuring stress, um, uh, and uh, and and to somehow understand the early symptoms of stress by using that kind of wearable devices like smartwatches.
Mm-hmm.
So we are interested in the early symptoms of stress. And now I checked one article yesterday. It's quite fresh, published this year, where they mentioned that it's impossible to measure stress by using that kind of smart sensors and smart watches. Uh, meaning so that the results are not significant what you are getting
Mm-hmm.
from the sensors compared how people are uh, having that kind of self-report instrument, that
Mm-hmm.
kind of how they are reporting their emotional mood or emotional stress by using self-report questionnaire or surveys.
Mm-hmm.
And they compared the results from the smart sensors to self report surveys, and they realized that there is no a proper connection between the association between. But uh, and that's what we try to do now, that we try to understand, are we able to use those sensors in in detecting the early symptoms of stress. But
Mm-hmm.
uh, I surprised that is this something new for me, or is it something that I should know more? But I checked it. Okay, you can have a challenge in both of issues. You and they say that the sensors are not measuring in the right way. I think that maybe the sensors are measuring in the right way, but how people are self-reporting things, it's also issue. So you can have a mistake in both sides.
Both, yeah.
Yeah. Not necessary. It could be that the sensor is okay, but people are doing. They are feeling the stress feeling may be a little bit different because they are
Yeah,
self-reporting. Yeah.
it's true. I think
Yeah.
we had a really nice presentation about it, like in last webinar on the 10th of December, about the stress and measuring stress in the SmartX Innovation
Yeah,
Hub.
they had. Yeah.
Yeah,
Yes.
it was,
Yes, they had. They had. That's one what we are doing as well, and then and the our issues that I'll be able to use. I know that we are. Actually I have used that kind of medical devices for measuring stress.
okay.
We have them, and I've used them. They are quite accurate. They are measuring quite well heart rate variable, and they are measuring skin conductive quite well. But are we able to use that kind of commercially available uh, affordable sensors like smartwatches? That's the issue, and how
Yeah,
reliable
that's
they
the
are. How reliable they are,
yeah.
and are you able uh, to make a decision that am I stressed or not by using your
Yeah,
devices? And the challenge is that, okay, this is a little bit out of topic of, okay, this is related to wearables, but the issue we understand now that we have both stress. We have positive stress with this eustress, and we have negative stress with this distress. And when you are using that kind of smart sensor, the wearable sensor is the smartwatch or other devices, it doesn't make a distinction between the bad and good stress. So it is giving a stress signal, and then you have to understand that which part of the signal is positive stress called eustress and which part of it is distress, negative stress. If you have had a sport and you don't know it tells you that you have a negative stress, distress, even if you have done sports.
Yeah, but maybe
So
we see the person. I mean, I think that's a tricky topic because you are involving as well how the person is feeling. Because maybe you can
yeah,
have a measure of a negative stress, but
yeah,
for the person is positive.
yes, yeah,
Because it's what you say. I mean, when you are doing sports, it's negative stress, but it's positive.
yeah. And if you check only the signal, you are not able to say anything about the signal if you don't know that what people are doing when they have from where the signal is measured, for what they have done during the signal. So then
Yeah, indeed.
you can say that is it positive or is it negative, and
Indeed.
that's the challenge. The that kind of smartwatch or any device is not telling it you. So
Yeah, I know. I mean, there's a lot of developments that we
yes,
need to do through it. Yeah.
yeah,
But I think we have a bit more disclose the program. Thank you, Kimmo, for the
no problem.
presentation, and we will share that probably early January and with the
Yeah, no
slides.
problem. Yeah.